Joining us now to talk about irrigation systems, Saleh Taghvaeian. You're our irrigation specialist here at Oklahoma State, and you've got some stuff going on here, but let's talk first of all, everyone's thinking right now we've had rain, it's a wet month. Why are we talking irrigation systems at this point?
Irrigation is very important in Oklahoma, especially the western part of the state. Irrigated lands play a major role in providing agricultural products that we consume every day. So even though we've had some rains, because of several years of droughts, we need even more rains, and we need to be very careful with irrigation management and using agricultural water resources.
All right, so along that line here in this field, you have an experiment going looking at management systems for irrigation. Can you talk about what you're looking at here?
There are several tools available to producers as far as irrigation management and scheduling. And here at this field, we're looking at some of these proven methods, and we're trying to test and fine-tune the methods and tools for specific conditions of Oklahoma, the soils here, the climatic conditions, the crops. The two important tools that we're testing here are the tools based on soil moisture and the tools based on canopy temperature. So if you look at here at this experimental plot, we have two infrared thermometers looking at the canopy from two different angles, and right in between the canopy temperature sensors we have soil moisture sensors installed at three different depths, 10 inches, 24 inches, and 36 inches, to look at water extraction by corn in the root zone area and to be able to monitor the changes in the water content that's available to the crop.
So tell me, what is this? Is this the sensor you're using there?
Yes, this is the sensor we're using, and over here inside this part of the sensor there's sand, and there's some coating and covering on it, and this, when we install it, it comes into equilibrium with the soil around it. And then there's two electrodes here that measure electrical resistivity. So if there's more moisture in the soil, we read a smaller resistance. If there's less moisture, it's dry, we read a higher resistance, and then we convert that back to soil moisture level.
So what will this experiment tell you about managing the irrigation in this system?
By looking at the data and seeing how these tools are sensitive to different levels of water stress, we can identify which one is more appropriate. And we also look at the cost of each method along with their sensitivity and their ability to predict water stress and to indicate the time that irrigation is needed. So we are developing thresholds for each of these methods where we can decide if this is the time to irrigate or if we can still wait and hold on irrigations.
Now, I understand you'll be talking about this experiment and some other things as well at an irrigation conference being held in Fort Cobb here pretty soon.
That's correct. We have organized this conference on August 19. There will be several very interesting talks about managing center pivot system, about managing subsurface drip irrigation systems, using smartphone apps for managing irrigation systems, using some of these tools for managing and scheduling irrigations. And we also have about a dozen different companies and dealers being there at the expo and presenting their products and be willing to talk to producers.
Absolutely. All right. If you'd like more information on that conference, you can find information on our website, sunup.okstate.edu.